So today is talking about different lines and forms of equations. That top one, that one is called what? Point slope. Good. Okay, because here's the slope, and right here and here is where a point is. You may recognize this from the top 20. One of the things that I told you should know is how to take 2 points and make the slope for it, and then put it into this form and understand point slope. For those of you that still haven't figured out your top 20, you might not be very good at this, but maybe this will be the thing that pushes you over the edge and helps you to get it. Do you get that they put in a 5 and a -3? So they had a point of -3, 5, and they had a slope of 2. You should know how to find slope. If you can't do that yet, I will review it with you in a second. All right, and then they've simplified it down by basically getting rid of the 2 negatives and making it positive, and then they just multiplied this out, and all of a sudden it's this. What form is that? Slope-intercept, because it's got the slope and it's got the y-intercept. Are there any other forms of an equation? Standard form. Very good. So let's go look at one of those. 2x plus 3y equals 12. That is called standard form of an equation. And technically they say ax plus by equals 12. And basically you can have, yeah, not 12. You can have any numbers here, here, and here, but I want to remind you that a, b, and c really should be reserved for x squared plus 3x minus 5. You remember that a, b, and c are really a, b, and c, where a, if there's nothing there, there's actually a 1 there. That's a, b, and c in a quadratic. Do you remember that? That's where you get the x equals -b plus or minus square root b squared minus 4ac all over 2a. Well, what are a, b, and c? That's these. That's a, that's b, and that's c, including the negative in front of the number. Okay? It's a power review of a lot of stuff that you've learned in the past. All right, slope. If I give you the point 2, 3 and 9, 12, you've got to be able to find the slope of that quick and easy, so I always start here. The last shall be first. 12 minus 3 over 9 minus 2 in this case. That's how you find slope. And it's the y value subtracted over the x value subtracted. And it equals m. So this one would be 9 over 7. 9/7 is the slope. And this is the rise, and this is the run. Okay, and this equals m. But wait, Mr. Server, you always said to clear fractions. Okay, watch me clear the fraction on this. I want to multiply both sides by x sub 2 minus x sub 1. And look at that. Does that look familiar? Point slope. If you didn't know that's where it came from, it's just the slope formula, but rearranged when you clear the fractions. Okay, so here's the x and the y have a point, and there's the slope. All right, next thing that I want to just remind you about that I think you probably heard at one point. If I want to be parallel to this line, what do I got to be? Is this parallel to that line? No, because what? Slopes. That slope is 2. What do I want to be parallel to it? Parallel to it. 2. Now, is this parallel to that? Yes, that means they will never touch. Unless they're on top of each other, which I can tell they're not because they're what's? Y-intercepts. If you are parallel to something, you're never going to touch it. Do you get, like train tracks, you know, this and this? They run forever and they never touch each other. Okay? What about something that touches and not only touches but makes right angles? 2 lines that do this. What are those called? Perpendicular. And then your slopes need to be, well, instead of 2, you'd use negative, not 2, 1/2. Okay? You don't just use the opposite slope, you use the opposite reciprocal. So if this had been 2/3, for a slope, you'd go 3 over 2. Because 1 over 2/3 makes it flip. We talked about this before. That makes it flip over and be 3 over 2. So if it started as positive 2/3, you'd change it to negative 3 over 2. And now you've got something perpendicular to it. Okay, so what if I give you an equation, y minus 6 equals 2 times x plus 7, and I say, I want you to write an equation for me that goes through 1 comma 2 and has a slope that's perpendicular. Write me an equation of a line that goes through 1 comma 2 and has a slope that's perpendicular to this one. Try it. You should be able to do it. Hint, y minus y1 equals m times x minus x1 is your friend. That's the key equation for today. Y minus y sub 1 equals m times x minus x1. Because if you know that, you can go, well, whatever point I use, I'm going to put in the x sub 1 and the y sub 1. Whatever slope I need, I'm going to put that in for m. Well, what point did I want? 1 comma 2. So I'm putting the 1 here and the 2 there. Why'd you reverse them? Because this is the x and this is the y. And then the slope I want, if I want it perpendicular to 2, then I want it to be negative 1/2. See, I still have an x and a y in my equation, otherwise it's not an equation. Raise your hand if you had that one right. Cool. What if I said put that in standard form? First thing I do is multiply it all out. Go ahead and do that. And then once you got x's and y's and a number called the constant, I'd shuffle it around so the x is first and the y is second. But I have a good tip for you. Stop. Did anybody even notice that we could clear the fraction? Didn't even think about it, did you? It's okay. You're normal. So I'm going to clear this fraction, and I think it's going to be a lot easier than what you're going to deal with if you still have a fraction. Because I am going to multiply this side by 2, and that side, which I distributed, by 2. And I'm going to have 2y equals, or minus 4, equals 2 times x minus 1. Do you get, I don't have to deal with fractions anymore then? Woohoo! My life's so much easier. You can do that, sure. As long as you multiply everything in the equation by 2. Ask it, Sam.
How did you get 2 x minus 1?
Because I multiplied wrong. Thank you. That times that, what is that actually? Negative 1, thank you. Okay, and now I'm going to have negative x plus 1. And then I'm going to have 2y minus, or I'm going to add 4 to both sides. Wait a minute. I said standard form. So let's get a plan. What do we want to have where if we want standard form? Yes? X and Y on the left. So, Anya, give me a tip on what I should do next.
You should either add 4 or add.
Okay, let's add 4, everybody. Why are you adding 4? Because you don't want the whole number on the left. You want the whole number on the right in standard form. 2y equals negative x plus 5. Okay, now what, Anya?
Now you add x plus 5.
And since I know I want the x first, I'm just going to make sure I put it first. Do you get that standard form? Did you know that if you had left the fraction in it, pay attention now, if you had left the fraction in yours, it would have been wrong anyways. Standard form is not allowed to have fractions in it. So if, for example, you had a 1/2 x plus 2y equals 6 or something, at the last step you would do, you'd still have to multiply everything by 2 to get rid of that fraction because you're not allowed fractions. I'm not saying this is the right final answer. I'm saying that if you had a fraction in your answer, that's not allowed in standard form. You got to clear the fractions anyways. One more reason that to clear the fractions is right on my list of the top 20. most important algebra topics, because you got to be able to clear fractions all over the place in math. To make something standard form, it has to have no fractions. Show you what I mean. You get all done with your problem. And you have that, and you're proud of yourself. That was really hard, and I had all these fractions all over the place, but I got it, and there it is. And now you're going to get it marked wrong because it has fractions in it. Can you clear the fractions? Would have been smarter to clear them at the beginning, but can you clear them now? Do it, because that'll put it into standard form. I know I keep banging on this top 20 drum, but do you see? They keep coming up. So Sam, tell me something to multiply everything by.
By 3.
All right. And a smart way to do it is like you said, and 5 at the same time. Because look, cancels. And now I have 10x plus 3y equals 21 times 5, 105, I think. Okay. Do you get that that's standard form because it doesn't have any fractions? Okay. Reason number 63 why the top 20 is very worth knowing. Okay. So, I feel like you know everything. So let's just flip these slides quick and see if you really do. Do you remember linear equations? Let's just talk about linear versus non-linear. Do you get linear as pretty much straight line? Non-linear means not a straight line. Okay, so linear, I know it just seems like the word line, but it is specifically talking about a straight line. Okay, so that's things like y equals 2x minus 7. Is that linear? Yeah, because this is a straight line. Is that linear? No, then it's got a curve. What if I put it to the third? Even more curves. What if I put an x squared here? Stranger and stranger, but more and more weird curves. And I mean, it's just harder and harder to know what this thing would look like. All right, so that's what I wanted to say about linear. Do you get if you have 2 points? You have to be able to find the slope of them. That's like baby talk by now. Got to be able to do that. Okay, then all of a sudden it's a math problem that involves points, but they're giving it context, and surprisingly it's about Sasquatch, because, and look at that, it's like a mountain that you'd see in Washington where these guys were that wrote the book. Suppose that 2 separate temperature readings were taken at the ranger station at the top of Mount Sasquatch. At 6 a.m. it was 24. Look at that, they made it into a point, 6, 24. And at 10 a.m. it was 32. Look at that, 10, 32. Okay, they just took data and they made it into a point. Then now what we're asking you to do in pre-calc that's different than higher algebra is to say, so what is your answer mean? So let's find the slope between 6, 24 and 10, 32. That's the easy part, find the slope. But then try to figure out what it means. Okay, so I got 32 minus 24. What is that? 8. You're right. Over 10 minus 6, what's that? 8 over 4 is 2. But what is it? 2 chickens per hour? Well, what is it? 2 degrees per hour. And how did I know it was degrees per hour? Because those things on the top, the 32 and the 24, do you get those were degrees? The things on the top were degrees. I drew over the 24 there, but do you get how those two were in degrees? So that's why we knew it was degrees. Over on the bottom, it was time, and that's in hours. 2 degrees per hour. Now, think about that. Do you agree that between, even in here in Minnesota, where it's not maybe as dramatic as on the mountaintop, we'll probably increase our temperature slowly today? Have you guys ever noticed what the hottest part of the day usually is? Is it noon around here? No. 2, 3, 4, something like that. Depends on the day, but it's never noon. Well, never is a big word. It's almost never noon for the hottest part of the day. Hottest part of the day is like 3, 4. Do you know what it is in different parts of the country? Totally depends. If you're in, I've been to Panama, which was kind of cool. Nope, not Panama, my bad. What's the one with the word equator in it? Ecuador, there we go. I've been to Ecuador, which is right on the equator. And weird thing there is that the time that the sun comes up in the morning is always exactly the same. And the time when the sun goes down at night is always exactly the same. Isn't that weird? Like the sun, there's no variability in their day. We'll get to that more later in a different chapter of our life here. But here in Minnesota, we have, like in the winter, our days are kind of short. And then in the summer, our days are kind of long. There, on the equator, the sun's always at its peak at noon, pretty much. And it's different. Okay, so anyway, 2 degrees per hour. We took points. We made slope into something that meant something in the real world. We gave it context. All right. Predict the temperature at noon. Well, if it's going up 2 degrees an hour and it was 32 at 10 a.m., then I just have to go up 2 every hour, and it's going to be 2 more hours. So I'm going to add 4. 32 plus 2 plus 2. 32 plus 4. Who had 36? All right, good. Okay. Standard form looks like that. Notice it says they're integers. If you don't know what that word means, technically, if they said whole numbers, what would have been wrong with saying that? Whole numbers can't be negative. If you didn't know that, that's important to know. Whole numbers start with 0. Just a fount of information today for you. But integers are like whole numbers, except they can also be negative. Okay. This one, slope-intercept form, you've known that one for a long time. This one you've gotten better at this year. And remember, if you're trying to convert over to this, you got to have no fractions. So you might as well, if you're in the middle of this and your slope is like 2/3, what are you going to multiply everything by? 3. Because you might as well clear it early. Who wants to add and subtract fractions and get common denominators and all that malarkey? Just clear them. All right. So I think this would be too easy, so we're going to skip over that. This is a graph these functions. Y equals 3. Oh my gosh, is it really that easy? Yep, it's that easy. What's this? It's got a slope of 3 and a y-intercept of 1. Again, we've practiced this on the top 20 because there's a little bit of graphing kind of stuff built in there. And I rise 3 and I run 1. Just a quick reminder that that's how that works. How am I going to graph that? Ew. Well, I just make points. Strongly recommend just finding points. Why am I not going to multiply this by 4 to clear the fraction? Because I got an f of x over this, not even a y. And if I did, I'm still not going to be able to see exactly where to, graph this thing. Could I do it one last way? Yes, I could. I could make this into 3 over 4 minus 2x over 4. Do you get what I just did there? I broke it up into 2 parts. I divided them separately by 4. And then if I rearrange it, it's negative 1/2 x plus 3/4. But I thought you said that they always had to not have fractions. No, that's standard form. We can have fractions in this form. Yes? It is -1. You are correct. I apologize. Thank you. Good catch. This line, I was just trying to gloss over them super quick because I'm like, everybody knows how to do this, and then I messed it up. So it has a y-intercept of -1, and it rises 3 and runs 1. Thank you. Okay, back to this. How would you graph the last one, though? That's the most nasty of them all. I don't have a good way to just zip, make it super easy. Do you remember my favorite saying? If you can factor it, you should. Can you factor it? Oh, yes, you can. And all of a sudden, x plus 2 and x minus 2 are on the top. And what's handy about that? The x minus 2 cancels. You seriously mean that's as easy as graphing y equals x plus 2? Close.
Yeah.
There's also a hole at
X equals 2.
x equals 2. Let's investigate that a little further. Okay, so we're going to graph that. It is as simple as y equals x plus 2, but there's a hole. No, I'm not writing that. But there will be a hole. Okay, anyway, I'm going to now graph y equals x plus 2. There, and then it's got a slope of 1, and so it's happily cruising along like this. And this is like a huge review of higher algebra. So if you remember higher algebra, you'll be like, boring. I knew about these a long time ago, but I bet you it's good to review it. So there's a hole here. Because of this x minus 2 on the top and the bottom, that's saying if I put in 2, the function will crash. And if you just look at this, you wouldn't think the function would crash. But if you look up above here, you can see that if you put in a 2, the function will crash. So you got to reflect that on the graph by saying when I put in 2 here, that will not work. So you put an empty spot right there. So much higher algebra. Okay. This one, does that look like distance formula to you? See why the top 20 have been handy to know? Okay, so they're making it more complicated though than just distance. Like distance formula's got to be like the back of your hand already. The Fight Club is the way I've described it before, where X's are fighting and the Y's are fighting, and there's a only plus sign and the whole thing is right between them. Have to climb over it to get from one fight to the other. All right, so y equals 2x minus 4. Well, I'm going to draw that. Here's y equals negative 4. Let's see if I can make the y-intercept right this time. And the slope of 2. And I've got this line. And then I want it to be things that are on that line that are 5 units from the point negative 1 comma 4. Where is that point? Negative 1 comma 1, 2, 3, 4. Is that negative 1, 4? No, Mr. Server, that is not. Negative 1, 4. There we go. Okay, now that I've drawn it, it's a little easier, but things that are 5 units from that. Would you agree there's a chance anyway that that might be 5 units away? How would I tell? Well, it's 2 and 4. Have you ever heard of the 2, 4, 5 triangle? No. There's no such thing as a 2, 4, 5 triangle. Okay, so it's not that. But would you agree there's probably, because they're asking the question, there must be some line where if you go just at the right angle or whatever, where you'll hit that line and the distance will be 5. So how do you do it? You don't want to do it from the picture. You want to use the formula. Would you agree that the point negative 1 comma 4 can be used effectively in this formula? You can put that somewhere, right? Okay. And how about the 5 units from it? Isn't that kind of a distance? So the distance is 5. And then I got an x and a y. I better put it in as one of them. I don't really care which one I put it in. So I feel like it'll look better if I go like this. X minus the x of this point is negative 1. Plus, oh, and it's squared. The y of this point, I'll put right there. And that y of this point is 4. Sweet. Now, do you get, I have included this info and this info. What have I not included? What part of the info they gave me have I not put in yet? That part. How in the heck am I going to put that in there? Don't overthink this. Look, I have an X and I have a Y. It's the only places I could put things. See, I have an X here and I have a Y here. It says that Y is 2X minus 4. I'm going to replace this y right here with, what do you think? 2x minus 4. Do you get that I have an equation now that only has one variable, and therefore I could solve it? I'm not going to make you solve it because it's got 8 million steps, but do you get them down to just only an x here and an x here, and you just have to multiply it all out? You'd square both sides to get rid of the square root. Don't forget, squaring both sides does not bring in absolute values. Square rooting both sides would, but I'm squaring both sides. And so this would be 25 equals x plus 1 squared plus 2x minus 4 squared. And then you could solve that. It'd be a quadratic. But quadratics have two answers. Exactly. We're supposed to find two answers. All right. I know that many of you would be able to solve this, some of you would not, so let's just go a little further. X squared plus 2x plus 1, that was me multiplying this out. That's a top 20 thing because some kids really suck at algebra. Plus, and then this part has to be squared, but first I'm going to simplify it. 2x minus 8 and then squared. So that's 2x minus 8 times 2x minus 8. So then that's 4x squared minus 16 is minus 32x. 8 times 8 is 64. And I'm bringing this all down. You seriously would have problems this big on the test? Absolutely. It's algebra. This is just algebra. You got to be able to handle algebra. That's why I make you be good at the top 20. That's why those of you that haven't got that fixed yet are, it's almost like you're trying to make this class hard for yourself. You gotta be able to have this part be easy. I mean, hey, you've seen me make algebra mistakes already on this lesson, but if you aren't willing to spend some time to make your algebra good, this class isn't gonna go real well. Double checking myself, plus 65, I think. And what it would, if this is like going to be so nasty that I can't factor it, well, you might actually be able to factor it because, but by the way, if you can factor it, you should. Could be followed up with, if you can't factor it, use the quadratic formula. But see how everything has a 5 in it? It's not going to be that bad. 5 comes out. X squared minus 6x plus 8. Oh my gosh, it's going to factor. Who would have thought after Mr. Server really de-emphasized factoring? It's clearly not a big deal in this class. And 4 times 2 makes an 8, plus it can also get me a 6. So I'm going to use a 4 and an x minus 2. And look at that. X equals 4 and x equals 2. Feels like I've been solving this problem forever, but I know if I got whole number answers, the odds of that being just a mistake are very low. So I think I've done it. And x is 4 and x is 2. Is that what they asked, though? They wanted the points. Well, I can tell you that the x is 2, and the x is, what was the other one? 4. But then I'd have to figure out the y's. Look right there. That'll tell you y's. Y equals 2x minus 4. All right. Do you get how higher algebra all of a sudden got way harder? That's what pre-calc is. It's higher algebra, but 16 different steps. All right, so I'm going to say y equals 2x minus 4, but what's x? It's 2. So I'm going to put a 2 there. And then I got y equals 0. Ooh, okay. And the other one is where I put in 4. So I got y equals 2x minus 4, and I know that x is 4. So then this is y equals 8 minus 4, and that's 4. 4 comma 4, 2 comma 0. That was a serious pre-calc question. It was mostly algebra. What was the pre-calc part of it? Knowing that you could put it all into one equation, and the rest of it was just algebra. Solving it down, factoring at the end, knowing that you can stick things back in. Once I know x is 2, I can stick it back in there. Okay. So it's not too late to fix your top 20, but he's getting close. November 10th is the last day of the quarter, and that's the deadline I set for you to get your top 20 fixed. Okay, some of you still have a top 20 that's like a B minus. It's hurting your grade, and it's meaning that moments like this, you're going to be less likely to do it. Get your top 20 fixed over the next 2 weeks. I'll be here in the morning, Mondays, Wednesdays, Thursdays. All right. I think that's enough. This is just going to be another problem that's got the same little context thing behind it, but basically you find the slope and then you figure out what the context is. And there's your homework. We chop some off. Let's take out this middle one. I recommend that on this one, let's take out this middle one. Otherwise, you just got a couple of points. And they just want the slope-intercept form of the line that goes through those points. Use this a lot. And find its slope, y-intercept and x-intercept. These are really good practice. Let's take out this one. And this is a little bit like that nasty one we just did a minute ago, but both of these are the types that we put on your test, so I think you should do both of them. On this page, I'm fine with us skipping. We don't need that many practices of them. Let's skip 69 and 70. This is saying here's an equation and here's a point, and you're going to use point slope to find the equation that goes through them. Oh wait, perpendicular to them. We practiced that. What's the slope here? -6. What's the slope perpendicular going to be? +6? No. 1/6 is correct. Good. Okay. And the challenge, you never have to do those, of course. And now you have a cut down assignment that's reasonable. And unfortunately, I am just plain not done with grading your tests, so I cannot give them back to you today. So I will pretty much guarantee to give them to you tomorrow. The other thing is there's a fair number of kids that haven't taken it yet, and so I would like them to have a little bit more time to take that. And if you're one of the kids that has not taken the test that we took on Friday, please come up and talk to me. One last thing, we haven't done one where we grade it in class for a while, the homework, so expect that to happen soon. So for instance, tonight, I just gave you this assignment. Maybe what we'll do is grade it. I'm not telling you we're going to do this. I'm saying maybe tomorrow we'll grade it in class and then drop it in the grade book after we've graded it. Okay, so do it. Be really smart to keep doing your homework.